Hi everyone, and welcome to our video on the polar form of complex numbers and de Moivre's theorem. So in this first video, we're just going to look at how complex numbers are graphed on the complex plane and then doing some operations and graphing with them. So graphing z equals a plus bi. So usually for complex numbers, we use the letter z. So z equals a plus bi is the form of a complex number. And on the plane, so complex plane, it's kind of like the xy plane. The x-axis, though, is the real axis. The y-axis is the imaginary axis. Okay, so if we're graphing a plus bi, it's looking at the real value part, going over however far you need to go. So positive to the right, negative to the left, and then looking at the imaginary part and going up or down how far ever you need to go. So for instance, oh, and before we do that, the modulus is the absolute value of our complex number. It would be the distance from the origin to the point. Okay, so that's all that means there. So a little bit of different vocabulary, but what we're going to see is that all of this is going to connect very nicely to our polar information, just with a little bit tweaking of the letters. Okay, so if we were to graph the following here, so number one, it says graph z equals 4 minus 4 radical 3i and its complex conjugate. Let's go ahead and we'll do that in blue. Complex conjugate, we'll explain what that is. Okay, but let's go ahead and get that graph going first. Okay, so here we go. I'm going to say, all right, so the 4 radical 3 is a little bit tougher to visualize, but I'm just going to say, well, the real part is 4. So 1, 2, 3, 4. And then this negative 4 radical 3i, so that's the imaginary part, the 4 radical 3 with the negative in front, means we should go down. Now, 4 radical 3 is probably about 8 or so. Okay, so 1, 2, 3, 4, 5, 6, 7, maybe about there. So somewhere about there. Okay, because I'm saying radical 3 is probably about radical 4. I'm just rounding. Okay, so it should go down that amount. So that's where that z is. So 4 minus 4 radical 3i is about there. So we can see it's in quadrant 4. Okay, so again, we did our real part and then the imaginary part on our x and y axis with respect to those two. Okay, the complex conjugate. So a conjugate just means to change the sign on the imaginary part. That's all. Okay, so that means, and we denote it with z with the bar on top. So that means on this problem, it would be 4 plus 4 radical 3i. Okay, so still 4 to the right, but then up 4 radical 3i, which I'm saying is still kind of about 8, is my guess. Okay, without actually plugging it into a calculator. Okay, so that's where z bar is. Okay, so that's how we can graph them. Okay, so it's almost looking like they're ordered pairs almost, like an x-coordinate and a y-coordinate. Okay, so let's go ahead and graph number 2. So number 2, z equals negative 3 minus 6i. Okay, so that would be 3 to the left, 1, 2, 3. And then the imaginary part has a negative 6 on it, so that's down 6. 1, 2, 3, 4, 5, 6. There we go. Okay, so that's where the z is. And its modulus, let's go ahead and do that one in blue. The modulus is just showing the length like that. Okay, so that's it. So that's the modulus, which that's the absolute value of the z. So absolute values are giving distances. Okay, so that's all this is doing as well. Okay, so that's how we can graph it. Number 3, okay, so here we get a little bit of different scenario. Okay, so in this expression, so they use set builder notation is what this means. They're saying the absolute value of z, so that's the absolute value of z, but we just said it's the distance. So it's saying the distance from the origin is between 3 and 6. So what that also really means, so the distance, any distance, so that means we have circles. Circles with radii 3 and 6. So the way that we'll sketch this, okay, so I've got 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. Okay, so I'm just finding the distance from the origin, that is 3. So actually, let's even color code this part so we can maybe see it better. So there's a distance of 3 from the origin. There's a distance of 3. There's a distance of 3, and there's a distance of 3. And then we just need to connect it with a circle. However, we do want to make sure we're paying attention to the inequality symbol. The less than or greater than would get dashed lines. Okay, so that means I need to draw my circle using dashed lines. Okay, so a little weird looking circle, but that's it so far. And then the second part, okay, so that one's less than or equal to. So less than or equal to or greater than or equal to would be solid lines that we draw. Okay, so but it's still saying I have z with a radius of 3 or 6. I mean 6 is I'm looking at, or the distance from the origin is 6. So here's a distance that's 6. Here's a distance that's 6. Here's a distance that's 6, and here's another distance that's 6. And then we just need to connect them with a solid line. Okay, so I'm just trying my best to draw a circle. Okay, so a little off right there. Let's just make it bolder. There we go. And then the in-between part, still, we would do a little bit of shading. Okay, so in between the two circles is everything right here. And there we go. Okay. Okay, I'm just using my gray. Okay, so that's just a different way. Again, so doing these short little graphs, just kind of trying to get used to the complex plane. Okay, so it's kind of like a donut or a bagel. Okay, so there's a blank hole in the middle. Okay, and then the dashed line, solid line. Okay. Okay, so that's the special case. So if you ever see that, anytime you see the modulus between two numbers as such, it really is just two little circles that we're going to be drawing. Okay, this last one where we're graphing, so it's saying it wants us to do z1 minus z2 if z1 equals that and z2 equals that. Okay, so let's go ahead and sketch z1, or not sketch, let's do z1 minus z2 real quick. So z1 is negative 2 plus 3i, and then minus z2 is negative 4 minus 2i. And then we'll just continue with our simplifying. So negative 2 plus 3i. This negative distributes. So it would be plus 4 plus 2i. And then we would combine like terms. So the real parts combine. So negative 2 plus 4 is positive 2. And then 3i plus 2i would be plus 5i. Okay, so that's what that z1 minus z2 is. And so now we can sketch that. Okay, so 2 to the right, and then up 5. And that's it. Done. Okay, so that's z1 minus z2. Okay, so that's how we can graph them. So sometimes we might need to do a little bit of operations first. Okay, but that's it. Okay, so that's our introduction to graphing these complex numbers. In our next video, we'll start to mix up the polar form of them and see how it's connected to previous sections. Okay, thanks for watching. We'll take a break, though, and I'll see you again soon.